Relationship between equivalent conductivity and normality. An electrolytic solution of normality n, capital N, contains n gram equivalents of the electrolyte dissolved per liter. That means 1000 centimeter cubed of the solution. That is the definition of normality. Therefore, in this case, the volume V equivalent of the solution containing 1 gram equivalent is given by the relationship V equivalent is equal to 1000 by n centimeter cubed. Combining the equation 2 and 3, that means we are going to compare the equations. What is V equivalent and what is delta equivalent? Then substituting the values, we get delta equivalent is equal to kappa 1000 by n, where n is the normality of the solution. Therefore, this can be written in words where delta EQ is equal to K into, that is kappa into 1000 by normality of the solution, because n represents the normality. The unit of equivalent conductivity per ohm centimeter square per equivalent. Based on this, the assignments are given. Please try to do knowing the derivation or the relationship between the normality and the equivalent conductivity. Similarly, molar conductivity, another term, molar conductance, which can be represented as delta M, small m, of the electrolytic solution. The conducting power of an electrolytic solution can also be expressed in terms of another quantity known as molar conductivity or molar conductance. It is represented by delta M and is defined as follows. Molar conductivity or molar conductance is the conducting power of all the ions furnished by 1 mole of an electrolyte present in a definite volume of the solution. Next is relationship between molar conductivity and specific conductivity. Just like how we derived the equivalent conductivity and kappa or specific conductivity, we have to derive another equation with molar conductivity and kappa. After that, you have to derive the relationship between molar conductivity and equivalent conductivity. Therefore, let us see what is the relationship between molar conductivity and kappa. The molar conductivity delta M is related to the specific conductivity kappa by the following equation. That is, delta M is equal to K by Cm, where Cm is the concentration of the solution in moles per unit volume. If 1 mole of an electrolyte is dissolved in Vm centimeter cubed of the solution, we know that Cm is equal to 1 by Vm mole per centimeter cube. This equation is more or less similar to the equivalent. Here only difference is C equivalent is equal to 1 by V equivalent per centimeter cube. That is the difference. Therefore, compare it when you are deriving the two equations. Combining the two equations 1 and 2, that is delta M and Cm, you arrive at another equation. Molar conductivity or delta M is equal to K by 1 by Vm, which is equal to, the molar conductivity is equal to K into Vm. It is to be noted carefully that the term Vm represents in the above equation represents the volume in centimeter cubed of the solution containing 1 mole of the electrolyte. That is the difference. The first one is 1 gram equivalent. 1 gram equivalent here, 1 mole of the solution. Therefore, derive both the equation. Then only we can derive the relationship between molar conductivity and equivalent conductivity. Molar conductivity or molar conductance of an electrolytic solution at dilution Vm is the conductance of the solution containing 1 mole of the electrolyte dissolved in Vm centimeter cubed of the solution. A relationship between delta M, that is molar conductivity, and molar concentration, that is molarity of the solution, can be obtained as follows. An electrolytic solution of molarity capital M, you already know the definition of molarity, which contains m moles of the solute dissolved per liter, that is 1000 centimeter cubed of the solution. Therefore, Vm is equal to 1000 by capital M represents the molarity. Substituting the value of Vm in the equation, delta M is equal to, that is molar conductivity is equal to kappa into 1000 by capital M. Now, where M is the molarity or molar concentration per moles per liter of the solution, or in words, molar conductivity is equal to kappa into 1000 by molar concentration of the solution. Molar concentration means molarity, and the unit of molar conductivity is equal to per ohm centimeter square per mole.